equations where we bring in the absolute value. So we need to solve with the absolute value. Well, if we remember, absolute value means the distance from 0 . So basically, if I have the absolute value of 3, it's the same thing as the absolute value of negative 3 because they're both 3 units from 0, right? So you never have a negative from there. You can't go a negative distance. So knowing that, if I look at my first equation here, the absolute value of x equals 12. So it's saying, what can I put in for x to make it 12? Well, the absolute value of 12 is 12, right? And the absolute value of negative 12 is also 12, correct? So I could say that x equals 12 and negative 12. Because I could plug a 12 in here, the absolute value of 12, right, is 12. And I could also plug a negative 12 into this equation, like I did over here. The absolute value of negative 12 is also 12. So basically, I got to think what could go inside of here to make this 12. Well, both a positive 12 and a negative 12 could do that. So what's going to happen is, essentially what happens is we take what's ever inside of here, and we set it equal to the positive and the negative part of what it's equal to, of what we want it to be. So we set x equal to 12, and we set x equal to negative 12. And that'll make more sense when we go through this example here. But first, before we do that, let's just evaluate some expressions to get used to our absolute values again. So evaluate the expression when a equals 5. So basically, I'm just plugging in 5 in for a. So let's go ahead and rewrite our expression here. So 5 minus 7 plus 15, the absolute value of 5 minus 7. And treat the absolute value bars like parentheses, right? So you got to do those first. They're your brackets. So I take 5 minus 7, which is negative 2. And the absolute value of negative 2 is positive 2. And 2 plus 15 gives us 17. So it's just plugging in for that variable and then going through and solving. So we actually get an answer there, right? Now let's solve some equations with the absolute value bars. It also says graph the solution set. Graph the solution set. So we're going to use a number line for our solution set. And we'll talk about that in a second. So let's think about this. The absolute value of 2x minus 1 equals 7. So basically, I want this whole thing to be either what? 7 or negative 7, don't I? Because the absolute value of 7 is 7, and the absolute value of negative 7 is 7. So I want the whole thing on the inside to be 7 or negative 7. So what I'm going to do is I'm going to take what's inside there, that 2x minus 1, and I'm going to set that equal to 7. And I'm also going to set it equal to negative 7. Because I want that whole thing inside of there to either be 7, like I just showed up here, or negative 7, because that'll make that equation true in both cases. And I just have two different equations to solve. So let's go to my left equation. I add 1 to both sides, and I'm left with 2x equals 8. So divide by 2, and x equals 4. So there's one answer, and then I do the other one. So I add 1 to both sides. 2x equals negative 6, divide by 2, and x equals negative 3. So I have two answers here, right? X equals 4, and it equals negative 3, right? If I plugged a 4 into our original equation, it would work. If I plugged a negative 3 into that original equation, it would work. And so now I graph my solution set. So I make a number line. Just make sure you have the furthest left number, so negative 3. And you can't just go like this and put 4. That doesn't work, okay? Give me an actual scale. So say, I can count by ones here. Negative 2, negative 1, 0, 1, 2, 3, 4. And I don't mind if you skip some numbers when you mark it. If you just say like 0 and then 4. And we just put a circle with it filled in to show that it equals that exact number. So there's my number line in the end. So you're setting up two equations, right? You want whatever inside the absolute value bars to equal the positive and the negative, right? Because the absolute value of both is going to give you your answer. So if you're still a little confused, let's try number 2. So I'm saying the absolute value of p plus 6 equals negative 5. So I'm thinking, what can I make this and take the absolute value of to get negative 5? Well, the absolute value of what gives us negative 5? Well, I hope you're confused because nothing, you can't take the absolute value of anything and get a negative 5, can you? If I did the absolute value of 5, it's 5. If I did the absolute value of negative 5, it's 5, right? So I cannot take the absolute value of anything to get a negative, can I? So over here, there is no solution. I cannot have absolute value bars equal to negative. That does not work. If I take the absolute value of something, I get a positive number. Okay, so there's no solution in that case. No solution. All right, let's go to another one where we get a solution. So same thing, absolute value bars, absolute value of 2m minus 4 equals 8. So I want what's inside of here. Well, let's see. How can I get 8? The absolute value of what? The absolute value of 8 is 8, and the absolute value of negative 8 is 8. So I want what's inside of there to be 8 and negative 8. So let's set up our two equations. So I want what's inside of there, 2m minus 4, to equal 8, like I set up here. And I also want what's inside of there, 2m minus 4, to equal negative 8, just like I showed. Because those both equal 8, right? The absolute value of both those. So let's go through and solve. Do the inverse of what's being done. Whatever you do to one side, do to the other. Same rules as always. Bring what's ever left down. Oh, wish I could add. And divide by 2. So m equals 6. And do the other one. Same thing. Add 4, add 4. Bring my 2m down. Bring my equal sign down. Negative 8 plus 4 is negative 4. Different step of 4 on that one. Divide by 2. M equals, well, negative 4 divided by 2 is a negative 2. And so m equals 6 and m equals negative 2. Let's go ahead and graph that. So I'll start with negative 2. Count by 1s again here. I can count by 2s. Negative 2 is 0, 2, 4, 6. That's fine. Just make sure you have a proper scale that it actually counts by the same thing. Circle and filled in, circle and filled in. Done. Number 4 is a little different. What do you notice? There's other stuff with that absolute value, isn't there? That's not on the inside of the absolute value. Well, in number 1 over here, I have the absolute value bars all by itself on the left side of the equal sign, right? I got to get that for number 2. So I got to get rid of this stuff and move it over to the other side before I can do what I've been doing and set up 2 equations. So first things first, I'm multiplying by a negative 3 with this absolute value, so it's stuck to it, so I can't mess with that yet. So we got to get rid of this 4. Well, the inverse of a positive 4 is a negative 4, or minus 4, right? Whatever I do to one side, I do to the other. So those cancel. I got to bring down my negative sign here. So negative 3 times the absolute value of k equals 10 minus 4, which is 6. And now I'm taking this negative 3 times that absolute value, so we got to divide by negative 3. That's the inverse. Whatever I do to one side, I do to the other. So those cancel. I get the absolute value of k equals 6 divided by negative 3, which is negative 2. Well, I cannot take the now I can set up 2 equations usually, right? But I can't take the absolute value of something and get a negative, can I? I can't do that, so I say there is no solution. So just remember, if you have extra stuff, like we did up top here, if we had some extra stuff, you got to get rid of this stuff and move it to the other side before you can set up your 2 equations like we did before. And if it ever equals a negative like it did here, absolute value equal to negative, there's no solution. Okay, good luck with working those absolute values.